Let's start the online lecture for topic 6, part 2. So let's first review the part 1, the first part of the topic 6. So what we have talked about in the previous lecture was random variable, definition of random variable. So if you have a sample space and there are basically all potential outcomes, all possible outcomes of an experiment, random experiment, and then we assign a value, a number to those outcomes. That is basically the random variable. So random variable is a function that assigns a number to an outcome of sample space, outcome in the sample space. Okay. And there are discrete random variable. If we can count the number of outcomes and we can assign those values for those like a countable number of outcomes, then it's a discrete random variable. If there is a very basically uncountable number of outcomes, for example, like a real number, all set of real numbers is the possible outcomes, then those rule that assign a number to those outcomes, those continuous outcomes, uncountable outcomes, is basically the continuous random variable. And then we also talk about probability distribution. So discrete random variable has discrete probability distribution. So basically countable number of probabilities. And there is a continuous random variable, which we will talk about. These guys we will talk about in topic 7. We will talk about this. And then we talk about expected value or expectation of the random variable x and the variance and the standard deviation of x. So we have population parameter mu, and now we have to introduce this random variable and its associated probability distribution. We can rewrite the expectation of x or expected value of x as summation over all x of this x times probability of capital X equals to small x. So when we use capital X, this is basically the random variable, and small x is realized value, right? And variance of x is summation all x minus mu square times probability, the associated probability. Okay, that was what we have done in the in topic 6, part 1, and today we will try to continue topic 6. So the rest of the topic 6, which is gonna be about joint distribution of two random variables. So we have now not just one random variable, but have two random variables, and we talk about distribution of those two random variables at the same time, right? So that is basically joint distribution or joint probability distribution. Let me write down joint probability distribution of two random variables, which is also called bivariate probability distribution or bivariate distribution. And we will also talk about, naturally we will talk about covariance between two random variables and correlation between two random variables. So sigma xy and rho, which is the correlation, where we can rewrite rho as a rho of xy, which we will discuss. And then there are typical discrete probability distributions. So one is the binomial distribution, and the other one is the Poisson distribution. Also, we will talk about Bernoulli distribution, which we will talk about before we introduce the binomial random variable and its distribution. Okay, so that's what we are gonna do today. And let's go to topic 6. So we stopped in the previous lecture. We stopped somewhere in here, like laws of variance, right? We stopped here. And then let's do some exercise. So monthly sales have a mean of 225,000. So monthly sale, we have this English word. So now we need to basically transform this into statistical language or statistical framework. So monthly sale has mean of 25,000. So monthly sale is basically X. Why? We have a bunch of months in a calendar year, 12 months, and then each month we will have a different realization of monthly sales or monthly sales, and that is gonna be the X random variable. X is basically monthly sale, and it has a mean of 25,000. So expectation of X is 25,000. Okay, 25,000. And standard deviation of X is basically 4,000. So standard deviation of X is 4,000. So standard deviation is sigma, which we will call standard deviation of X, which is 4,000. Okay, that means what? Variance of X sigma square. Variance of x is 16 million, right? 60 million. Okay, so variance and standard deviation is given, and profits. What we have to do is profits are calculated by multiplying sales by 30% and subtracting fixed cost of 6,000. So profit, we will just say profit as y. Okay, another random variable. Monthly sale is a random variable. Profit is also random variable, and then profit is calculated by multiplying sales by 30% and subtracting fixed cost of 6,000. So y is equal to 30% of x, 30% of x minus fixed cost of 6,000, right? So y is basically 0.3x minus 6,000. Find the mean monthly profit. So we want to find the expectation of y. Okay, let me write down usual parenthesis. Expectation of y. The expectation of y is what? Expectation of another usual parenthesis. 0.3x minus 6,000. Okay. And then we run this. Expectation of cx is c times expectation of x, right? Expectation of cx is c times expectation of x. Expectation x plus c is expectation of x plus c. So expectation of, if a and b are constant, then a expectation of x plus b when a, b are constant. Okay, when a and b are constant, expectation of ax plus b is a expectation of x plus b. So this is gonna be 0.3. So first, let's take it out 6,000 first. So expectation of 0.3x minus 6,000. So this is constant and this is constant. So expectation of 3.3 expectation of x minus 6,000, and we know expectation of x. This is what 25,000. So this is gonna be 0.3 times 25,000 minus 6,000. So this is gonna be 1,500. Okay, 1,500. So this is how we can calculate expectation using the rule of expectation, laws of expected value, right? So we use this laws of expectation or expected value. Okay, we use laws of expected values here. Next, let's move on to this question. Find the standard deviation of monthly profit. Standard deviation of y. We want to find standard deviation of y. Then maybe we need to, because we know the variance, the laws of the variance, so we can use variance of y, and variance of y is variance of 0.3x minus 6,000, right? So y is 0.3x minus 6,000, which we know. So this is basically the reason why we introduced the random variable. The random variable, we can always talk about the other random variable as a function of another random variable, right? So this is a good thing about this using a random variable. And then variance of what? Variance of cx is c square variance of x. Variance of x plus c is variance of my English, I'm so bad at writing, handwriting. So variance of x, and so variance of ax plus b is a square variance of x when a, b constant, right? So this is basically the rule for variance, and this is rule for the expectation, laws of expectation, laws of variance. So this is gonna be variance of 0.3x, which is 0.3 square variance of x. So that is 0.09. Variance of x was what? 20. Is it 20? 16 million, right? 16 million. So this variance is what? This variance, write down this. Actually, this was what? I have to calculate this. Okay, 16, which is 59, 1, 44 0000 like this, right? 144 0000. So that is what 1,044 1,440,000 1,440,000, right? Then the standard deviation of y is simply the square root of the variance of x, variance of y, of course, variance of y, which is what 1,200, right? 1,200. So that is the how we calculate the standard deviation y. Of course, you can just rewrite down this as standard deviation y is standard deviation of what 0.3 x minus 6,000. Actually, in terms of standard deviation, this guy still cannot contribute to the standard deviation, right? Standard deviation. Also, but you may not know how to apply this law of the variance in terms of the standard deviation. So let's try to do this as a square root of variance of y. Okay, then that is square root of variance of what? Variance of 0.3 x minus 6,000, right? And this is gonna be square root of the variance of 0.3 x, and this is gonna be square root of 0.3 square variance of x, right? Square root of 0.3 variance of x, then that is 0.3 times square root of variance of x, that is 0.3 standard deviation of x, and standard deviation of x was what? 4,000, right? So that is 0.3 times 4,000, which is this. You can also write solve it this way. So this may be a simpler way to calculate this, but I just try to use definition directly, right? So you can use this way to calculate this, or you can use this way to calculate this, right? So that is totally any method is fine. Okay. And there is another exercise. The manager of a bookstore recorded X as the number of customers who arrive at the checkout counter every 5 minutes. And following distribution was calculated, and calculate the mean and standard deviation of the random variable X. So let me leave this for you as a quiz today. So today's quiz for quiz today. So please solve the mean and the standard deviation of this random variable X, expectation of X, and standard deviation of X, sigma. You calculate this, and then submit this as your answer as a PDF file. Okay, PDF file. You answer this question. Okay, so that is your quiz today. I'm gonna move on to bivariate distribution. Okay, bivariate distribution. Up to now, we have looked at univariate distribution. Univariate means just one random variable. Okay, RV, one random variable. So probability distribution in one random variable, and as you might guess, bivariate distributions are probabilities of combination of two random variables. Bivariate means basically two variables, right? Two random variables. For bivariate probability distribution is basically for x and y, two random variables. So it is basically the joint probability distributions. So there are two types of events, and we talk about the distribution of probability of, for example, A and B. And this is joint distribution, right? Joint probability. So we are talking about the joint probability distribution. So so joint probability distribution. So joint probability distribution of x and y can be a table or a formula or graph that reads the joint probabilities for all pairs of values x and y. So if x take two values 0 and 1, y take three values 0, 1, 2, 3, then there are six possible pairs: 0, 1, 0, 2, 0, 3, 1, 1, 1, 2, and 1, 3, something like this, right? So if x has two values, y has three values, and three possible pairs, right? So we basically write down that as associated probability as a table. So probability of x, capital X is small x, and capital Y is small y. Or we can rewrite this as probability of small x, small y. And as in the univariate probability distribution case, the joint probabilities joint probability distributions must satisfy these two conditions. One condition is this probability. Each probability must be between 0 and 1. Okay? Each probability must be between 0 and 1. 확률 언제나 0하고 1 사이. Okay? And then second property is if you sum them up, all those joint probabilities over all x, all possible values of x and over all possible values of y, so two sums, right? Two summations, then this summation must be equal to 1. All those possible probabilities you add up, then it should be 1, right? All pairs of x, y, if you add up those joint probabilities, then that probability must be 1. Okay, let's look at the example in the next slide. So there are two real estate agents, agent A and agent B. Let X denote the number of houses that A sells in a month, and let Y denote the number of houses agent B sells in a month. Okay, and an analysis of their past monthly performances has the following joint distributions. So X and Y, those are agent A and agent B. Agent A and agent B only sell up to two houses, right? 0 house, 1 house, or 2 houses, right? 0 house, 1 house, and 2 houses, right? There are three possible values. So it's two discrete random variables. Discrete random variable X, which takes 3 values, 0, 1, 2. Discrete random variable Y, which takes 3 values, 0, 1, 2. Okay? And then this probability is what? This is probability of X is 0, Y is 0. So both agent sells no houses, right? Okay, that is basically probability 0 and 0. And this is both, agent sell 2 houses. And this one is A sell 2 houses, but B sells no house, right? So that is this kind of probabilities. And this probability is given, right? This is basically joint probability distribution, okay? This is the joint probability distribution. It's a table, okay? Nothing but just table. And then from this, we can calculate the marginal discrete univariate marginal probabilities. So this, for example, if you add up these 3 numbers, right? Plus, then you will get what? 0.12 plus 0.42, which is 0.54. So plus 0.06 is 0.6, and this is what? Let's think. This is probability of Y equals to 0. Agent B sells no house. Okay, and here 0.21 plus 0.06 plus 0.03 is a 0.3, which is probability of Y equals to 1. 0.1 is probability of Y equals to 2. So there are 6% chance the agent B sells no house, 30% chance 1 house, 10% chance 2 houses, right? We can also do this in the column sum, as a column sum, 0.12 plus 0.21 plus 0.07, then this probability is 0.4, and this probability is gonna be 0.5, and this probability is 0.1, and this is probability of X is 0, probability of X is 1, probability of X is 2, and this add up, you will get 1, right? Add up, you will get 1. Okay, so these are basically the marginal probabilities. We got the marginal probability and joint probabilities. Before we move on to the next slide, how about calculating the expectation of X and expectation of Y? Expectation of X, do you remember expectation of X is what? Summation of over all X times probability of X equals to small x. Okay, so X can take 3 values, 0, 1, 2. Right? And probability, associated probability is these 3 guys, right? So 0 times 0.4, 1 times 0.5, 2 times 0.1. Okay, so that's gonna be the expectation of X. So 0 times 0.4, 1 times 0.5, plus 2 times 0.1. Okay, so this is gonna be 0, so 0.5 times 0.2, so 0.7. So that means what? In a month, agent A is likely to sell 0.7 houses. So mean houses agent A sells in a month is 0.7. Okay, so expected value of Y is summation or Y times probability of Y equals to Y. always it's better to practice. Okay, and when you practice in the exam, you may not need to write down this kind of formula here because you have a time constraint. But when you do a practice, it's better to write down the definition, mathematical definition, and also the English word definition of every kind of concepts or terms, right? So y summation y times the associated probability. So y is 0 times 0.6 plus 1 times 0.3 plus 2 times 0.1, which will give us 0.5. So half. So 0.5 houses the agent B will sell in a month as an expected value. Okay, so that's the expected value of X and expected value of Y. Okay. Now let's move on to next slide. So this slide is gonna be about the covariance and correlation. Okay, when we know the bivariate distribution of two discrete random variables X and Y, the covariance is gonna be defined as this. Okay, how this comes from? Covariance was what? Covariance of two things X and Y was expected value. Actually, have we calculate summation of all summation of I equals 1 to n. What was this? Xi minus mu x, yi minus mu y divided by n. This was the covariance of X and Y. So basically what we are going to do is we take average of these over all basically possible values in our population. So that means we are also taking the weighted average of this product of the differences, right? So X minus is expected value, Y minus is expected value, and we sum them up over all possible X and Y. Okay, and this weight is probability of X equals to small x, y equal to small y. So that is the joint probability, right? Joint probability. So that is, if you remember this expected value of x was a summation of all x probability of x equal to small x. And this, I mentioned many times that this part is basically the expectation, right? Expectation part. Here we have this summation and the joint probability. So this is basically expectation of something, and this something is this. Okay, so this is expectation of x minus mu of x. Mu of x is what? Mu of x. Mu of x is expectation of x, and y minus expectation of y. So mu x is expectation of x. Mu y is expectation of y. Okay. So, and if we rewrite down this, then we can show that this is equal to expectation of x times y minus expectation of x times expectation of y. This is very useful formula, by the way. This is very useful formula that you may want to remember. Okay. So the coefficient of correlation, right? Rho of xy, or sometimes people call it correlation of x and y. This is covariance xy divided by standard deviation of x times standard deviation of y. Okay. So in the next slide, we will try to calculate the covariance of this x and y using this joint probability distribution, and I will use both formula. One formula is this formula, and the other formula is this formula. So we will try to solve this, calculate the correlation and covariance using the joint probability distribution. So I copy and pasted joint probability distribution here. Okay, joint probability distribution here. So I will use this to calculate covariance and correlation between x and y. Okay, and this was page 22. Okay, page 22. So covariance of x and y. Let's write down the formula. All x, all y. X minus mu of x, y minus mu of y, probability of x equal to small x, y equal to small y. And how many combinations? We have 9 combinations. 9 combinations here. Okay, we have 9 combinations. 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 1, 2, 0, 2, 1, 2, 2. So 9 combinations of these. Okay, there are 9 combinations. So we have to write down all those 9 combinations. So let's start from 0, 0, 1, 0, 2, 0. So 0, x is 0. And expectation of x, mu x, was what? We already calculated this in the previous slide. And expectation of y was mu of y was 0.5, which we already calculated, right? So 0 minus expectation of x 0.5. 0 minus the expectation of y 0.7. 0.7, 0.5, right? And probability of x is 0, y is 0. This is what? This is a 0.12. Okay? Plus 1 minus 0.7, 0 minus 0.5, probability of x equals to 1, y equals to 0. This is what? 0.42. Okay? Plus 2 minus 0.7, 0 minus 0.5, probability of x is 0, x is 2, y is 0, right? And that is what? 0.07, 0.06, right? 0.06, right? Okay, I'm doing this for another. So here, let me write down here. This is x, and this is mu x. This is y, and this is mu y, right? X is 0, y is 0. Here, x is 1, y is 0. Mu x, mu y, oops. Mu y, right? Plus now 0 minus 0.7, 1 minus 0.5, probability of x equals to 0, y equals to 1, which is what? 0.21, plus 1 minus 0.7, 1 minus 0.5, probability x equals to 1, y equals to 1. This is 0.06 plus 2 minus 0.7, 2 minus 0.7, 1 minus 0.5, and times this 2 minus 0.2, 0.02. This is a probability x is 1, y is 2, right? Plus 0 minus 0.7, 2 minus 0.5, probability x is 0, y is 2, which is 0.07, plus 1 minus 0.7, 2 minus 0.5, times 0.02. Actually, this is not 0.02, right? X is 2, y is 1, right? This is what? This 2 minus 2 and 1, so this, right? 2 and 1, 0.03, right? This is probability of x is 2, y is 1, okay? Plus 2 minus 0.7, 2 minus 0.05 times 0.01. Once you calculate this, then you will get minus 0.15. Okay, very tedious. You may wonder whether we have to do this kind of tedious job every time. The answer may be yes or no. So let's try to use different method to calculate covariance of x and y. Covariance of x and y is expectation of xy minus expectation of x times expectation of y, which is given here. We want to use this formula. Then what we have to calculate is expectation of xy. Because we know expectation of x is 0.7, expectation of y is 0.5. So 0.7 times 0.5. So the calculation become much easier now. We only need to know expectation of xy. Then how can we calculate the expectation of xy? That is the problem. Now let's go back to this, okay? And then now let me write down z is x and y, okay? Z is x and y. Then x and y, this z can take how many values? X, if you multiply x and y, then what z can take is 0, 1, 2, and 4. There are four possible values that z can take. When z is 0, z is 0 means what? 0, 0, 0, 1, 0, 2, 1, 0, and 2, 0. When x is 0 or y is 0, then z is always 0. So this probability, right? So if you add up these probabilities, then basically you will get probability of z is 0, right? Probability of z is 0. So probability of z is 0 is sum of these 5 numbers, right? These 5 numbers, which will give us 0.88, okay? 0.88. Z is 1 means what? Z is 1 means 1 and 1, okay? This is the only case probability of Z is 1. And probability Z is 1 is what? 0.06. This number, right? This number. And probability of Z is 2 is 2, 1. X is 2 or y, X is 2 and Y is 1. And X is 1 and Y is 2. Okay? So probability of Z is 2 is sum of these two numbers, right? So 0.05. Probability of Z is 4 is 2 and 2. So probability of Z is 4 is 0.01, this number, right? Then expectation of Z. How can we calculate the expectation of Z? Expectation of Z is summation all Z times probability of Z is small z, right? Z can take 4 values. 0 times 0.88, the associated probability. 1 times 0.06 plus 2 times 0.05 plus 4 times 0.01. So this expectation of Z is what? Let me find out. This 0.2. 0.2. This is the expectation of XY. Expectation of XY is 0.2. So we can try to, use this expectation of XY, plug in this expectation of XY is 0.2, then 0.2 minus 0.35, so which is minus 0.15. Okay, this is how we can calculate the expectation of XY and use this expectation of XY to calculate the covariance of X and Y. Okay, and this will lead us to be able to calculate covariance of correlation of X and Y. So correlation of X and Y. Correlation of X and Y. So rho of XY is covariance of XY divided by sigma X, sigma Y. Sigma X and sigma Y, I'm not going to calculate this. I will just give the number for you guys. So covariance of XY is minus 0.15. And sigma X, you can try to calculate this sigma X using this table. Okay, sigma X, the variance of X, the standard deviation of X was what? Was 0.64. 0.64. Sigma Y is 0.67. So 0.64 times 0.67. So you will get minus 0.3498. So that is going to be covariance. You can verify this by yourself. Okay, that's what I want to mention. Okay, so you can verify this correlation. Let's move on to the next page. Sum of those two variables. So the bivariate distribution allows us to develop the probability distribution of any combination of the two variables. Of particular interest is the sum of two variables. So sum of those two variables. So let's say z, now z is x plus y. And we want to calculate the expectation of x plus y, expectation of z, okay, expectation of z, expectation of z. So in Australia, we call it z instead of z. In the US, people call it z, right? So expectation of z is x plus y. So it is expectation of x plus expectation of y. Variance of z, variance of z is variance of x plus y, which is variance of x plus variance of y plus something. Okay, so this is going to be our formula that is given in the next slide. Actually, this is 2 times covariance of x and y. So this is going to be the formula that we are going to use in the next slide. But if we don't know this formula, then how can we calculate this? We have to write down the value x plus y that can be realized. Then we actually do this similar thing for x times y, right? X times y can take 0, 1, 2, 4. X plus y, 0, 1, 3, 4, right? 0, 1, 2, 3, 4. Actually, 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. So if we use this formula, then when x plus y is 0, means, let's go back to the next slide. This means what? This means 0 and 0. And this means 1, 0 and 0, 1. This is a 1, 1, 2, 0, 0, 2. This is 2, 1, 1, 2. And this is 2 and 2. So we can write down the corresponding probabilities, right? And 0, 0, probability of 0, 0 is 0.12. So 0.12. And this one is probability of x plus y is 1 is 0.42 plus 0.21, so 0.63. And this is 1120 and 02, so 0.06. Sorry, this number is going to be 0.19, which is 0.06 plus 0.07 plus 0.06. And this is going to be 0.05, which is 0.03 plus 0.02. And this is going to be 0.01. Okay, for example, this number is from 21 and 12. 21 and 12, so 0.05, right? So 0.05. So then how can we calculate expectation of x plus y? Expectation of x plus y is basically expectation of this guy. So 1 times 0.12 plus 0 times 0.12 plus 1 times 0.63 plus 2 times 0.19 plus 3 times 0.05 plus 4 times 0.01. So which we will calculate this, which we can calculate this, which is 1.2. But we can use this formula, x plus expected value of x plus expectation of y is 0.7 plus 0.5, which is 1.2. Much easier. We don't have to even write down this kind of table, the probability distribution of the sum. Variance of x, we can also calculate this. Variance of x plus y is what? 0 minus 1.2 square times 0.12 plus 1 minus 0.12 square times 0.63 plus up to 4 minus 1.2 square times 0.01. Then we can calculate the variance of x and y, but we don't use this formula. Don't use that. Instead we use the formula that variance of x is variance of x. Variance of x plus y is variance of x plus variance of y plus 2 times covariance of x and y, which is what? Variance of x is actually, I haven't given you the variance of x, but variance of x is 0.41, variance of y is 0.45, and covariance of xy is minus 0.15, right? So plus 2 times minus 0.15. This will give us 0.56. Okay, that is the variance of x plus y. Okay, I kind of go over went over this a little bit quickly, but please if you have any questions, please let me know. Like this, I use this variance formula which is given in the next slide. So variance of x plus y is not just variance of x plus variance of y. Instead, there is a 2 times covariance of x and y here. Okay. So in the next slide, there is a laws of the expectation of x plus y and variance of x plus y. So expectation of x plus y is expectation of x plus expectation of y. Variance of x plus y is variance of x plus variance of y times plus 2 times covariance of xy. So when x and y are two random variables, x, y, two random variables, a, b, two constant, then expectation of ax plus by is a expectation of x plus b expectation of y. Variance of ax plus by is what? A square variance of x plus b square variance of y plus 2 times ab covariance of xy. Okay, this is the generalization of this formula. Okay, this is the generalization of this formula. You can simply verify this by adding up those, like multiplying those constant in front of the those two random variables. But I just want to, I'm not gonna prove this, but you can still, simply easily prove this by yourself. If x and y are independent, the covariance of x and y is 0. Okay, this is an interesting feature. So those two random variables are independent, then covariance is 0. Then variance of x plus y is variance x plus variance of y, because covariance plus 2 times covariance of xy, and this is 0. Okay, when two random variables are independent. Let's move on to binomial distribution. So before we talk about binomial distribution, we have to talk about binomial experiment or binary experiment. So binomial experiment, and actually we have to talk about Bernoulli process first and then binomial experiment. Binomial experiment have the following properties. We have a fixed number of trials represented as n, and then each trial, there are a fixed number of trials. We do this trial many times, but each trial is a Bernoulli process, which has only two possible outcomes. One is a success and the other is a failure. So basically like tossing a coin or flip a coin. It's not a Bitcoin. It's tossing a coin, like you toss a 100원짜리 동전, tossing a coin, and you get head or tail, right? And with the head, you have a probability P, and tail, you have probability 1 minus P, right? If this is 0.3, then this is 0.7, right? There are two possible outcomes, only two possible outcomes, and one probability is P, then the other probability must be 1 minus P. We have this Bernoulli process, and we do this process n times. Okay? You toss a coin n times. 동전을 n번 던지는 겁니다. And the success probability is a P, and the failure probability is 1 minus P. So this is a success, and this is failure. Success and failure does not mean a good thing or bad things. It's just we call it success and failure. You can call it head and tail. You can call it good and bad, whatever. It's fine, but just the two things. Okay, that is a Bernoulli process, and we do this Bernoulli process n times. Okay, then let me write down one thing. One thing is this. So Bernoulli distribution. Before we talk about binomial distribution, Bernoulli distribution means this. When we have x is a random variable which has only two outcomes, 1 and 0, like tossing a coin with the probability P, and with the head, with the success with probability P, with the failure with probability 1 minus P. So 0 is failure, 1 is success, probability P, and 1 minus P, right? And this distribution can be written as this. Probability of x equal to small x is P to the x times 1 minus P to the x. If you But if you include x equals to 1, then this is gonna be p times 1 minus p to the power 1, 1 minus p to the power 1 minus 0, so it's gonna be 1 when if x is 1. And this is gonna be p to the 0, 1 minus p to the 1 minus 0, so this is 1 minus p if x is 0. So we can write down this kind of Bernoulli process and its associated distribution and random variable like this. And the probability distribution has a formula that p to the x times 1 minus p to the 1 minus x. And we can write down this as xi. It's an ith trial of this Bernoulli process. So x1, first draw of a coin, first toss of a coin. x2, second toss of a coin. x3, third toss of a coin. And xn, nth toss of a coin. You toss a coin n times. If you sum these xi's, I equals 1 to n, and this, let's call this as a y, and this y has a binomial random variable. X is a binomial, y is a binomial random variable and has a binomial distribution, which we will talk about in the next slide. So y is basically the sum of xi's. Okay, what does it mean? What does this sum means? You have success and failure. Okay, two possible outcomes: success and failure. Okay, and then you do this trial n times. Okay, trial n times. So and then you count the number of successes, right? So this y is the number of successes in n trials. Let me repeat this in Korean. 한국말로 한번 하겠습니다. 동전을 n번 던져요. 예를 들어 100번 던집니다. 그러면 x1 첫 번째 동전 던진 거, x2 두 번째 동전 던진 거, 1, 0으로 다 나올 수가 있는 거죠. 헤드 or tail, 헤드 or tail. xn 100번째 던진 동전. 그러면 이거를 다 썸합니다. 얘를 다 썸하면은 이것도 여러 번 어떻게 던졌느냐에 따라서 몇 번 성공했을지가 다 다르잖아요. 그렇기 때문에 y도 랜덤 베리어블, 이 썸도 랜덤 베리어블인데 이 썸 몇 번 성공했는지, 그렇죠? 몇 번 앞면이 나왔는지를 카운트한 겁니다. 이 카운트한 얘가 바로 바이노미얼 랜덤 베리어블이 됩니다. Okay? Very important. This is very important. Each person, you think about a person who is employed or not. Employed is 1, 0 is unemployed. You have 100 people, then basically you are adding those each person's employment status n times, right? So that is basically this kind of Bernoulli random variable, and sum of those Bernoulli random variable is a binomial random variable. Okay, so binomial distribution is basically success and failure, and this success and failure is just the labels. It doesn't mean a good thing or bad things. Okay, and head is a success, tail is a failure, and employed is a success, unemployed is failure. Okay, single is a success, married is a failure, or something like this, or married is a success and single is a failure. Okay, so a random variable of binomial experiment is defined as the number of successes in the n trials, and is called binomial random variable. So y is a binomial random variable which is summation I equals 1 to n xi. Xi is a Bernoulli random variable with the probability p, success probability p. We can write down like this. So x is a 1 and 0 random variable with success probability probability of xi is 1 is p. Then y is basically summation of those xi's over n times. Okay, n times. Okay, if you flip a fair coin 10 times, then this is a fixed number trial, and each trial has two possible outcomes. Probability success is 0.5, probability failure is 1 minus 0.5, which is on another 0.5, right? And the trials are independent. If you toss a coin once, and the next toss of a coin basically doesn't depend on the first toss, right? Or the previous tosses, right? So basically, these trials are independent. These trials must be independent. Okay. So flipping a coin 10 times is a binomial experiment since all those conditions are met. Okay, satisfied. And this binomial random variable counts the number of successes in n trials of the binomial experiment, and it takes the values 0 to n. So you can have a success 0 times or 1 times or n times, right? All possible numbers are basically 0, 1, 2, 3, 4, up to n. Okay, and this is a discrete random variable because it can take this y can take only n numbers. Well, you can think about this as a x or yi is a Bernoulli random variable. Okay, Bernoulli p, probability p, and x is summation I equals 1 to n yi. It doesn't matter whether you fix x as a Bernoulli, y as a binomial, or y as a Bernoulli, x as a binomial. Okay, then this probability associated with each value of x, okay, x is binomial random variable, then probability of x, capital X is small x, is n factorial, this is n factorial, divided by x factorial, n minus x factorial. This looks like a very intimidating feature, but this is basically what n choose x, or this is n c x, which you may have learned in high school or middle school. So this is n choose x. Okay, n choose x. Okay, n choose x, which is n factorial. N factorial is what? N factorial is n times n minus 1 times n minus 2 times times 1, right? This is n factorial. So n factorial divided by x factorial, n minus x factorial, p to the x, 1 minus p to the n minus x for all possible values of x. And this is a binomial probability distribution. So x is a binomial probability distribution with two things you have to know: n and p. N is number of trials, and p is the t is the success probability. Okay, you can write down the x is distributed from binomial distribution with n trials and p success probability. Okay, so this is a binomial distribution. So find the what is this? Let's look at this example and find the mean, or find the probability of each question. Probability in each question. So stat dude is a not good student taking a statistics course, and this guy's exam strategy is to rely on luck for the next quiz. So quiz consists of 10 multiple choice questions, and each question has 5 possible answers, 5 multiple choice questions, 10 multiple choice questions with 5 choices, and only one of which is correct. So 5 and one of which is correct. And Pat plans to guess the answer to each question. Okay, each question. And what is the probability that Pat gets no answers correct? Okay, so we have to transform this English into the word. So we have to say yi is basically the random variable that Pat, this guy, gets correct answer for the i's question. Okay, and this yi can be a 1 or 0. 1 if correct, 0 if wrong. Okay, and this yi is 1 with probability p, and this probability is 1/5 because there are 5 possible choices, and the chance that he gets or she gets the right answer is 1/5. And this with the wrong with the probability 1 minus p, which is 4 over 5. Okay, then what is the probability that Pat gets no answers correct? Means we have this x, which is the number of answers, number of questions Pat gets correct. This is a new random variable, which is a binomial. This is actually the summation I equals 1 to n yi. Okay, And this is basically binomial random variable with n and p. And n is what? How many questions? 10 questions. P is 1/5. Okay, 1/5, right? And this probability of x is small x is n choose x. Okay, and p to the x 1 minus p to the n minus x, which is given here. Okay, n choose x. So n choose x, p to the x, 1 minus p to the x, and n is what? N is 10. So 10 choose x. So let me rewrite down this with a factorial. 10 factorial, x factorial, 10 minus x factorial. P is 1/5, x, 4/5, 10 minus x. Okay. Then the question asks probability of x is 0. Probability of x is 0. So you can write down this 10 factorial, 0 factorial, 10 factorial, 1/5, 0, 4/5, 10 minus 0. Okay. By the way, this 10 factorial is 1. 10 factorial is 1. So this is going to be cancelled out. And this is going to be 1. And this is 4/5 to the power of 10. So 4/5 to the power of 10. Okay. And this is going to be 0.1074. Okay. So there are 10% chance that this guy gets no answers correct. Okay, no answers correct. So probability of x equals to 0. What is the probability that Pat gets 2 answers correct? So probability of x is 2. Probability x is 2 is 10 choose 2. P is 1/5 to the 2. 5/2 to the 10 minus 2, which is gonna be 10 factorial, 10 factorial, 2 factorial, 8 factorial, 5 1/5, 0.2 to the 2, 0.8 to the 8, which is 0.3020. 0.3020. Okay, so that's how we calculate the binomial probability for binomial random variable. Okay. If you have questions, please let me know. Binomial distribution, binomial table. So calculating binomial probabilities by hand is very tedious and error prone. So there is a table for finding binomial probabilities. I'm not gonna emphasize too much about this because these days we can use computer or cell phone to calculate this probability without using the table. So when n is 10, we can use this table. N is 10 and k is basically how many questions that Pat gets correct. So 2 questions correct, okay, with probability 0.2, 2 questions correct with the n equals 10, with the probability 0.2 is 0.6778. I think that this is gonna be this is actually probability, is a cumulative probability. So probability of x is less than equal to 2. So in order to get probability of x equal to 2, then probability of x is less than equal to 2 minus probability of x is less than equal to 1. Okay, then this probability is 6778. Probability of x is less than 1 is this 0.3758. Okay, then this is gonna give us 0.302. Okay, so this is how we calculate the probability of x equal to small x using this table. Table only give this cumulative probabilities. Okay, and one thing that I want to mention is the formulas for the mean, variance, and standard deviation of binomial random variable. So x is a binomial random variable with n trials and success probability p. then expectation of x is n times p, variance of x is np 1 minus p, standard deviation of x is square root of np times 1 minus p. This is a interesting formula, and you may want to calculate the mean and the variance of y. Y is 1 and 0 with probability p, with probability 1 minus p, expectation of y, variance of y, and standard deviation of y. This expectation is p, variance of y is p times 1 minus p, this standard deviation is square root p 1 minus p. Okay, this random variable. So expectation of y is 1 times p plus 0 times 1 minus p, so it is p. And you can also calculate the variance and standard deviation. Okay, this is another thing that you may want to remember. So y is a Bernoulli distribution, then the expectation is p, variance is p times 1 minus p, standard deviation is square root p times 1 minus p. Okay. Next, Poisson distribution. Okay, Poisson distribution. So named for Simon Poisson. The Poisson distribution is a discrete probability distribution and refers to the number of events or number of successes within a specific time period. So in the previous binomial random variable is a number of successes for n number of trials. But now the Poisson is a number of successes for specific lengths of the time, or specific lengths of the region, or specific area of the space. Okay, so the example is this. So number of cars arriving at the service station in an hour. So hour is the interval, okay, specific time. And the number of flows in a boat of clothes. So in a boat of clothes is this, basically like the 천한 roll. It's like a roll. Okay, roll. The specific region is a roll of clothes. Okay, and the number of accidents in one day on a particular stretch of a highway. So this is 1 day in a section of a highway. Okay, both time, day, space, the interval. Okay, 1 day stretch of a highway. So that is a length or interval. So basically an interval, given an interval, what's gonna be the occurrence, the number of occurrence in an event. Okay, that is the what Poisson distribution describes. Okay, like a binomial experiment, Poisson experiment has 4 defining characteristic properties. Okay, there are some characteristic properties that defines Poisson experiment. So the number of successes that occur in any interval, that occur in any interval is independent of the number of successes that occur in any other interval. So first an hour, there are 2 successes. Then next hour, okay, there is a number of successes, but that successes doesn't depend on the first hour's successes, right? Number of successes. So the probability of a success in an interval is the same for all equal sized intervals. So in the first 1 hour and then second 1 hour, right? First 2 p.m. to 3 p.m. and 3 p.m. to 4 p.m. that those 2 events, the probability of one success is equal. Probability of a number of successes, if it's a probability of 2 successes in first 1 hour, and probability of 2 successes in the second 1 hour is going to be the same. Okay, and probability of success is proportional to the size of the interval. If you give me 1 hour, then the probability of one success is 0.5. Then if it's 2 hour, then probability of one success is basically multiplied proportionally. Okay, that is basically the third property. And probability of more than one success in an interval approaches to 0 as the interval becomes smaller. Interval is small. For example, like you think about only very small interval, like 1 second. How many successes? What's the probability of the success? If you talk about the interval very small, then those probabilities gonna approach it to 0. Okay, that is the 4 properties of this Poisson distribution. Okay, and then Poisson distribution is basically the number of Poisson random variable is the number of successes that occur in a period of time or an interval of space. in a Poisson experiment. For example, like 96 trucks arrive at the border crossing every hour. Then x, this is basically x random variable, which is probability x is 96. So probability of x is basically in here the number of trucks arrive at a crossing in every hour. Okay, the number of typographic errors in a new textbook edition. This is random variable y, which is also Poisson random variable. Okay, this is a Poisson random variables. Okay. Oh, and sorry, this is not x is 96, and this means what? Let me explain this again. So on average, 96 trucks arrive at the border crossing every hour. Then x is the number of trucks arrive at the crossing every hour. Then this average 96 means expectation of x is 96. Here y is the number of typographic errors in a new textbook edition. Then average 1.5 edition per 100 pages. Per 100 pages is y. This is y. Then expectation of y is 1.5. Okay, so in 100 pages the interval. Okay, and a border crossing every hour is an interval. Okay, and expectation of x is 96. Expectation of y is 1.5. Okay. And how about the distribution? Poisson distribution. Poisson distribution look like this. So probability of x is small x is e to the minus mu to the x divided by x factorial. E here is the Euler number. Okay, Euler number. E is like 2.71 blah blah blah, right? This Euler number. And x can be any number from 0 to infinity, right? So countable numbers, but it's 0 to infinity, discrete. Okay, where mu is the mean number of successes in the interval. So this mu is a parameter, population parameter. This is expectation of x, which is mu, expectation of x. And actually the variance of x here is equal to sigma square, which is actually mu. So we don't have to worry about sigma square. Actually, variance of x is also equal to mu. That is very interesting property of the Poisson. So Poisson distribution, mean and the variance are the same as mu. Okay. So let's try to solve some question. Okay, solve some question. A statistics instructor has observed that the number of typographic errors in new editions of textbook varies considerably from book to book. Okay, so the number of typographic errors in new editions of textbook. Okay, and some analysis, he concluded that the number of errors in Poisson is Poisson distributed with a mean of 1.5 per 100 pages. So we can define a random variable x is the number of typographical errors in a textbook per 100 pages. And this question gives that mean is 1.5. So expectation of x is given as 1.5, which is mu of x, or just mu. You can just rewrite it down this as mu. Then the instructor randomly select 100 pages of a new book. Okay, new book is given. What is the probability that there are no typos? So probability of x is 0 is the probability that we want to calculate. So the probability of x is small x. The Poisson distribution is e to the minus mu to the x, and x factorial for x is 0, 1, 2, which is e to the mu is 1.5 given here, and 1.5 to the x and x factorial. So probability of x is 0 is e to the 1.5 minus, actually e to the minus 1.5, 1.5 to the 0, x is 0, and 0 factorial. And this number is given as e to the minus 1.5, which is similar to 0.2331. Okay, 2331. Again, we try to translate our English word into the statistical framework. The important thing is how to define a random variable, and this number means what? This number means the expectation. Okay, so that is the important thing to calculate this. Let's move on to next question. Please try to solve this question by yourself first, and then let me go over this. Okay, I ask you to stop the this recording and just solve this question, and then try to see how I solve this question. Okay, let's assume that you already solved this question. Okay, now suppose the instructor has just received a copy of a new statistics book. He noticed that there are 400 pages. What is the probability that there are two or a few or typos? So let me write down y is a new random variable. And then this is the number of typos in 400 pages of a new book. Okay. Then in order to calculate the probability of y is 2 or fewer, so 2 is probability y is less than or equal to 2. We want to calculate this. Then we have to basically define this probability of y equals to small y. E to the minus what? E to the minus mu of y, mu of y to the x. Sorry, it's not gonna be x. It's y and y factorial. Okay, because this guy is a Poisson random variable. Okay, Poisson random variable, and expectation of y is mu to the y, and we have to know this guy. Okay, and good thing about this Poisson is this 400 pages. When there are 100 pages in the previous slide, 100 pages, there are 1.5 errors as an expectation. Expectation of x is 1.5 in 100 pages. Okay, in 400 pages, what's the expectation of these errors y? That is 1.4 times 4. Okay, 1.5 times 4. Okay, so expectation of y is basically 4 times expectation of x, because 400 pages, 100 pages, there are 1.5 errors. So this is expectation of y is 6. So e to the minus 6, 6 to the y, and y factorial. And probability of y is less than equal to 2 is what? How to calculate this? Probability of y is less than equal to 2 is y is a discrete random variable. So what y can take is 0, 1, and 2. So probability of y equals to 0 plus probability of y equals to 1 plus probability of y equals to 2. Okay? And this is going to be e to the minus 6, 6 to the 0, 0 factorial, plus e to the minus 6, 6 to the 1, and 1 factorial, plus e to the minus 6, 6 to the 2, and 2 factorial. Okay? And this number, you calculate this, then 25 times e to the minus 6, which is close to 0.062. Okay? In the exam, it's okay, you leave this as a 25 times e to the minus 6. Okay, that is totally fine. But I just want to show what is going to be the probability. Okay, there is a 6.2% chance that the typo is less than or equal to 2 in 400 pages. Okay, if you have any questions, please feel free to let me know. This lecture was a little bit longer than the previous lectures, so maybe I will make the other lecture a little bit shorter than this. Okay, thank you.